This is a video about arithmetic average return, geometric average return, and compound annual growth rate, or CAGR. Nothing in this video is financial advice, and I'm not a financial advisor. I'm examining some definitions in mathematics arising in investing. This video is solely for educational purposes. Let's look at an example. Tom's portfolio is worth $100,000. In 2021, he loses 50%, and in 2022, he gains 50%. His arithmetic average return, or AAR, is 0%. His geometric average return, or GAR, is minus 13.4%. What is Tom's portfolio worth at the end of 2022? At the end of 2021, he lost half his value, so it's worth $50,000. At the end of 2022, he gained 50%. Half of 50%, or half of 50,000 is 25,000. So he added 25,000 to his 50,000, and his portfolio is worth 75,000. So over 2 years, he lost 25% of his value. In order to break even at the end of 2022, he would have needed to double his money, that is, earn 100% return in order to get back to zero. That is, get back to a portfolio value of $100,000. Which measure of average annual return, AAR or GAR, is more accurate? Well, an AAR of 0% over 2 years would give you a portfolio value of $100,000. A GAR of minus 13.4% over 2 years would give you a portfolio value of $74,995.60. His actual value is $75,000. Clearly, GAR is a better measure of average annual return. However, a GAR only depends on the product of the returns and the number of time intervals that we're considering. And the formula of the GAR is given here. It's 1 plus R1 times 1 plus R2 up to 1 plus Rn, all to the 1 over nth power, take the nth root of that, minus 1 times 100%. Here, R1 is the return in year 1 in decimal form. So a 12% return in year 1 would mean R1 is 0.12. R2 is the return as a decimal in year 2, and so on. If S1 is your starting amount of investment, then 1 plus R1 all times S would be the value of your investment at the end of the first year. In order to illustrate the ease of computation of arithmetic average return, suppose his returns were minus 50% in 2020, plus 50% in 2021, plus 8% in 2022, plus 20% in 2023, minus 30% in 2024, and plus 50% in 2025. His AAR would be 8%. Now, earning 8% a year for 6 years would leave a portfolio value of $158,687.43. But the actual value of investment with those annual returns would be $102,060, and the GAR would be 0.34% per year. Let's look at another example. Judy has a portfolio value of $10,000 at the beginning of 2015. She earns 10% per year in odd years and 0% in even years for 10 years. Her AAR is 5%, and that's easy to compute. However, her GAR is 4.88%. At the end of 2024, her actual portfolio value is $16,105.10. If you had an AAR of 5% over 10 years, your portfolio value should be $16,288.95. However, an annual return of 4.88% over 10 years would leave you with a portfolio value of $16,103.74. The actual value of our portfolio was $16,105.10. So once again, the GAR is a better measure of average annual return. Let's look at some examples of GAR. Suppose you earn 20% in the first year and 5% in the second year. Your GAR would be 11.25%. Suppose you went on for one more year and earned 15% in that third year. Then your GAR would be 13.16%. If you have two different portfolios, And their returns in decimal form are R1 through Rn and S1 through Sn. And if 1 plus R1 times 1 plus R2 up to 1 plus Rn is equal to 1 plus S1 times 1 plus S2 up to 1 plus Sn, then the two portfolios have the same GAR and they have the same, assuming they started with the same value, they have the same terminal value. Suppose your portfolio starts with $100,000 and you earn the following returns. You lose 50% in the first 3 years and you gain 100% in the next 3 years. In this case, your AR is 25%, but your GAR is 0. Now, if you look at this, if you lose 50% of 100,000, you get 50,000 in the first year. Half of that is 25,000. Half of that is 12,500. That's the first 3 years. Then you double the third year, you get 25,000. You double it again to get 50,000. You double it again to get 100,000. In the end, you finish with $100,000, which is the same as what you started. That implies you have a 0% interest. In this case, the GAR is a more accurate reflection of your portfolio value. Suppose instead you gain 50%, you gain 25% and lose 20%. Then you gain 25% and lose 20%. Then you gain 25% and you lose 20%. In this case, your AAR, your arithmetic average return, is 2.5%. Your GAR is 0%. If you look at your portfolio balance, you began with $100,000 and you end with $100,000. And once again, the GAR is a more accurate reflection of your portfolio value and of your annual return. What is CAGR, or compound annual growth rate? Well, the formula is given here. You take the nth root of the ending value over the initial value minus 1 times 100%. So Beth buys stock on January 1st for $10,000 and sells it for $12,000 on July 1st. So the time period is half a year. So N is 1/2 year. Her CAGR is the ending value, 12,000, divided by the initial value, 10,000. That gives me 1.2. You then square that because the reciprocal of a half is 2. If you square 1.2, you get 1.44. 1.44 minus 1 is 0.44. You multiply that by 100%, you get a 44% annual return. Now, if the question is, what's her semi-annual return? It would be 20%. She earned 20% in half a year. But her annual return, her compound annual growth rate, was 44%. Notice that GAR and CAGR are very similar. If the time periods are years and the ending value is the initial value times 1 plus R1 plus 1 plus R2 up to 1 plus Rn, then GAR and CAGR are the same thing. Now, CAGR is not a true return rate. If assume that your rate was constant over all n years, then the ending value you'd get by assuming CAGR was your steady return would give you your actual ending value. So it's the rate that your investment would have grown if it had grown at a steady rate each year. It ignores the volatility of returns.